We are still on solving right angle triangles. In the next two clips, we are going to look at the special area of application, angles of elevation and depression, where we use trigonometrical ratios and possibly the Pythagoras theorem to solve right angle triangles. Problems that has to do with angles of elevation and depression normally result in a right angle triangle. First, what do we mean by angle of elevation? As you can see on the screen, the first picture we have there, you can see the woman standing there. Here is her eye level. Ordinarily, that's her eye level. She wants to take proper sight of the airplane. In order for her to do that, she has to do what? Elevate her eye level. That is, she has to raise her head up through some angle. That angle through which she raises her head, say from here up there, that angle there, let's call it angle theta, is what is called the angle of elevation. That is, at least the angle through which she had to elevate her eye level in order for her to focus on the airplane. As simple as that. There's nothing so special about angle of elevation. Let's look at the second diagram down there. Look at the eye and look at the object to be sighted. Ordinarily, the eye should have an original eye level there, horizontal to the floor. In order to focus on this object, the eye is what? Raised or elevated through this angle. That angle through which the eye is raised, we call it whatever we like, you can call it theta, is known as what? The angle of elevation. In solving problems that has to do with angle of elevation and depression, there is a key word that we must take note of. That word is from. If I am to give an expression or a description of this angle of elevation, I will describe it this way. Let me change the color of my marker. I will say that the angle of elevation of the airplane, angle of elevation of what? Of the airplane, because that's the object we want to sight. Then we'll now describe where is the angle of elevation taken from. We'll now say from the eye of the woman, in this case, is, let's say, 30 degrees. Take note of the word from. It's very, very important. It tells you where the angle of elevation is actually being measured. So right now, this is our from, that point. So we stay here, look at the eye level, and then take our angle of elevation there. From here, from the eye level up to the line linking the observer with the objects that we are trying to sight. Similarly, in this case, in the second case, the object, the eye, is our from. So we are taking our angle of elevation from this point of this object. So the angle of elevation of this object from the eye that we have there in second image will be given as what? As theta, or whatever it is. Let us look at angle of depression. On the screen right now we have another pair of images. Now we want to look at angle of depression. Assuming we have an observer lying there, up here. Originally, you will agree that this is what? The eye level of that observer, horizontal. Now this observer is interested in the boat on the sea. In order for the observer to take proper sight of the boat, he has to do what? Depress, that is lower his eye level from there, the horizontal level up there, down to the line linking him, right, with the object. That angle through which he has depressed his eye level is what we call the angle of depression. So I can call this angle theta or whatever. Let's look at this gentleman here with his face cap. He's interested in this object. Probably he has some properties there that he's interested in. Rather than just looking straight, which is expected as the original eye level, because he's interested in this object, what does he do? He will depress his eye level that way, down, through some angle, whatever it is, we call it theta. And look at the object here. If this object is interested in looking at this man, it has to do what? Raise his eye level up to sight the face cap of the man standing there. Again, the word from is also very important. When we are taking angle of depression, where are we taking it from? Of course, from the top. We want to see something that is down. So we say angle of depression of this boat from the top of this cliff. So that's why we take the angle of, so we depress that way. And in this case, the angle of depression of this object from the eye level of this man. So that's where we are taking our angle from. Now with this, let's move in and see how we can develop our right angle triangle. Here I have a tree. I want to look at the angle of elevation of the top of the tree, from the point A. If I were to have my eye level at A, that is horizontal this way, and I want to take sight of the top of the tree, what do? I will have to do what? Elevate my eye level that way through the angle theta. So this therefore is what the angle of elevation. If you look at this, you can see that we have defined a right angle triangle. How? Because this tree obviously is standing upright, so we expect this there and then up there to be a right angle triangle. And from here we say, okay, that's the angle of what? Elevation, theta. Oh, applying our SOHCAHTOA, the side, this other side here is going to be what? The height, h given here. And then this side is going to be our adjacent. This is opposite because it's facing the considered angle. Of course, this is the hypotenuse. I will look at, okay, I want to do what? Relate the height of the tree to the distance of my position A from the base of the tree, which is x. So tan theta is opposite, which is h divided by adjacent x. Move further. What about if the case has to be that of depression? Angle of depression. Here we have the angle of depression of B from O. This, you are at O, you want to look at B. So you have to depress through this angle. Doing this, we have a right angle triangle there, as you can see. Let's say this is our cliff or some building. So that's the height of the building. That's the distance of the object that we are sighting from the foot of the building. Say Y. And we have a right angle triangle. Of course, the angle of depression is outside our triangle. The angle of depression, it will always be outside the triangle. But what do we do? It's a very simple thing. The line drawn up there and the horizontal line AB are obviously parallel. So we say alternate angles are equal. So we transfer the theta up there into this position of B. So we can have our angle of depression in there. And then again, we apply our trigonometrical ratios. Again, tan, we say this is going to be our opposite facing the considered angle. That's the hypotenuse. And then this is the adjacent. Of course, tangent is what? Opposite over adjacent. So that's tan theta is h over y. Excuse me, please. Let's now take an example, a life problem. Example 1 here states the angle of elevation of the top of a tower from a boat. The top of a tower from a boat. Let me change this to white. Take note of from a boat. Where is the boat? On a sea. So if I say, okay, my sea cannot be in the sky, the sea has to be down there, it means my boat can be somewhere here. I can call that boat B. From the top of a tower, say I have a tower there. Of course, we expect it to be making 90 degrees with the horizontal. The angle of elevation of what? Of this top from B. We are taking from. So we are taking to what? From here, that angle that joins the line linking here to the top. And that is our diagram. Sorry? Let's look at it there. So that's it. Let's call this our boat. I'll call this the top. You can give this whatever you like. If you like, and call it the ground. So you can see that what? That the angle of elevation from B, the boat, angle from here to there, which is what? 30 degrees, is the angle of elevation of the top of this tree from this boat. And here we have a right angle triangle. So what do? We solve. We are looking for what? The question says, if the tower is 150 meters tall, which is there, calculate the distance of the boat from the foot of the tower. The distance of the boat from the foot of the tower. There. Which means we are referring to this distance. From this triangle, we have this as x. We have been given this side 150. It is facing our angle 30. So we call this side the opposite side. And we are looking for the adjacent side. Since this is the hypotenuse facing the right angle. I say, okay, in that case, that I am going to use tan because opposite and adjacent, considering as so, car, tour. Opposite and adjacent are being done, combined by what? Tan. So I say tan of the angle 30 will be the opposite side, 150, divided by the adjacent side, which is not known. And from here we can solve. You can see there, tan 30 is equal to 150 over x. Remember, we are still making use of our special angles. So instead of going to get the actual value for tan 30, I simply put it what? As 1 all over root 3. Remember, tan 30 is 1 over root 3. And then rearranging this, cross multiply, we have x equals to what? 150 times root 3. And that's the distance of the boat B. Remember, our boat is there. From the ground, or sorry, the foot of the tower. Let's take one more example to end this video clip. Example 2. From the top of a palm tree, a pine wine tapper observes that the angle of depression of his bicycle parked 3 meters away from the base of the tree is 70 degrees. He's right on top of the tree, so we are taking our angle of depression from that top where he is. That's where his eye level is, and he's trying to focus on what? On the bicycle. Calculate the height of the tree. Let's look at that diagram beautifully. Here we have the man or the palm wine tapper there. And that's his eye level dotted. In order for him to do what? Focus on his bicycle, which is parked somewhere there. That's his bicycle. What does he do? He has to depress his eye level there down so he can take proper view of his bicycle. And that angle we are told is what? Is 70 degrees. But we know, as we saw earlier on, that this 70 degrees is outside the right angle triangle that we have just formed here. Look at the line linking the two of them. And this is the palm tree. It's height h. We then transfer 70 inward since alternate angles are equal. So this is 70 degrees. And we have a right angle triangle because I expect our palm tree to be standing upright, being vertical to the ground. How do I find the height? Looking at this triangle, the right angle triangle, again, our SOHCAHTOA can be applied. This is my opposite. Of course, this is going to be the adjacent. Why is it the opposite? Because it is facing the angle that we are using, 70. And you can say, okay, that means that tan of the angle 70 is equals to what? Opposite, which is the height we are looking for, divided by the adjacent, which is 3. And we manipulate this, And we have tan 70 given to us as 2.7475 equals to h over 3. Cross multiplying there, we have that the height is 3 times 2.7475. And that gives us h as what? 8.2425. That's it for our intro into elevation and depression. In the next video clip, we'll take some more engaging problem still on angle of elevation and depression.